What are proportions? If you're going to solve them, you better figure out what they are. But basically, it's just two ratios that are equal to each other. Think about it this way. When you have a fraction and it's 50/100ths or 50/100, you could simplify it down to 1/2. When we look at ratios, we know we can write them as a fraction, and we know that 50/100ths is equal to 1/2. They are equivalent to each other. And so as a result, we're going to take that same type of skill, basically simplifying fractions, and we're going to set them equal to each other. And then we're going to look at some kind of weird properties that happen when you see that. When you look at proportions, if you actually multiply the numbers that are diagonal of each other, like 100 and 1, you see they're diagonal to each other. 100 times 1 is 100. But when you take a look at the other two diagonals, they will always equal the same number that you got the first time. Well, 50 times 2 is 100. And that's how you can actually do a test to see if the two ratios are proportionate. So if it's a little too difficult for you to see if you can simplify a really large fraction and make it the same as the smaller fraction, um, essentially you can actually take this test and multiply the diagonal numbers and be able to see if you get the same product. So that's a little test that you can do. So here we have two ratios. They look just like fractions because that's the style that we wrote them, but hey, 2 to 3 is the same as um, 200 to 300. That's how we read ratios, right? 2 to 3 is equal to 200 to 300. Well, there's a couple of ways we can find out whether or not this is a proportion. Okay, here's the question. Do these two ratios make a proportion? Ratios that make a proportion are equivalent to each other, they're equal to each other. Well, I know that if I take 100 and multiply it by 2, I get 200. And if I take the same number of multiplication, 3 times 100, I would get 300. So yes, that's a proportion. Okay, if you do it that way, you're done. Here's another way that we can do it also, though. 200 times 300, I'm sorry, 2 times 300 is 600. What's 3 times 200? 600. If you get both of the products that are the same, you'd say, yes, it's a proportion. If you got something like 600 and 400, you'd say, no, sorry, it's not a proportion. So let me show you a situation that you might come across where it's not a proportion and you've got to figure it out. How about 2/3 equals 30 over 40? Well, 2 times 15 gets me 30, okay? But 3 times 15 does not get me 40. It gets me 45. So that is not a proportion. Then you can also do the cross multiplication way to multiplying the diagonal numbers. 3 times 30, so there we go. 3 times 30 is 90, but 2 times 40 is 80. Is this setup of these two ratios, does it make a proportion? No, because you don't get the same product. Over here, yeah, because you both got 600 when you did the cross multiplication, so yes, this would make a proportion. And that's what it comes down to. That's the basics. That's the very baby steps of a proportion. Now let's take a look at finding a missing number in what we know is a proportion. Before we jump into that, let's take a look at two ratios and prove that they are proportionate. Um, 10 times 3 is 30, and 12 times 3 is 36, so that's one way to prove it. Another way is 12 times 30. So we pull up the calculator here. 12 times 30 is 360, and 10 times 36, 10 times 36 is 360 also. So yes, this is a proportion. We've proven it two different ways. You only need to prove it once, but I just like keep showing you two different ways so you feel a bit more comfortable for it. But let's just say that we don't know one of the numbers. One of the numbers missing below, but we have the other three. In this case, you've got two ways of doing it. For the easier ones like this one, you can say, well, 10 times 3 gets me 30, so I just need to multiply the bottom by 3. And 12 times 3 means that x equals 36. That's great for the easier ones. However, for the ones that may have a decimal in there, we have a little bit more um, algebraic method, I guess you could say. I was going to say more of a flashy method because people usually love this. They feel very smart once they do that. Here's what it is. We know that if we multiply these two diagonal numbers, we would get 360. We proved that earlier. 12 times 30 is 360. And we know 10 times this number would also equal 360 because um, well, it's proportion. I know that 10 times whatever this number is going to get the same number. We've done that enough. Unfortunately, we don't have it. So all I know is that 360 equals 10 times x. So let's write 10 times x, 10 times x. And now you've actually got an equation. 360 equals 10x, so why don't we just divide both sides by 10? So that way we can free the x. And that means 360 divided by 10 is 36. And that's what we said we knew it should be. See, it was 36 originally. This x should have been 36, and this works. So let's go and try this new method here. I know 12 times a number equals 36, so 12 times 3 is 36. So 10 times 3 equals 30, and that's one way of doing it. But here's the second way. I know that 10 times 36, see, let's just multiply these two numbers together here. 10 times 36 equals 360. And let's put an equal sign here. And I know that 12 times x, now listen to me, we know that 12 times x should equal 360 also. So this 12 times x is going to equal the 360 we got from multiplying this first diagonal set. And that's why we know it's true. The next two times that I explain this, I'm going to go straight into the steps and just show you exactly what you can do without having to overthink it, okay? With this cross multiplication, that's what this is called. 12 times x, so let's divide it by 12. Divide the other side by 12, and we get 30, actually, for the answer. 30 will equal x, and so this would equal 30. Now, let's just clear off all of this ink so that way it doesn't get in the way. And let's use our cross multiplication method only to solve this one. We could use the other one, but we just want to use cross multiplication. You take the two diagonal numbers from each other. So 12 and 30 are diagonal for each other. I don't start right off with this one. Take the two numbers that are opposite of each other, diagonal, and multiply them. So 12 times 30 would equal 360. And then you just divide by this number right here. 360 divided by 36 is 10. To take it a little bit further though, 36 times x, you could write it like this, 36 times x. And if you just have these two products equaling each other, 12 times 30 is 360. The 36 times x is 36x, because we don't know what x is, but that creates an equation. So we can now divide by whatever number is beside that x, because it's multiplying it, and divide the other side by that same number, and suddenly you're in business. You know that this x is actually 10, and we knew it should be 10 from that original proportion we set up. So let's do one other just so that way I can show you this works no matter what number is missing from these four spots. 10 times 36 is 360. X times 30 is 30 times x, or 30x. So now we can divide by 30, divide by 30, and guess what? X equals 12. Because once you put it into your calculator, let me just show you this one. This 360 divided by 30, 360 divide by 30, it really does get you 12. This video is getting a little bit longer. What I'm going to do is I'm going to flip up about 2 or 3 other random proportions that are missing a number. You should pause the video, solve them, and then come right back and hit play and see if you're right or wrong, and see what went wrong. Okay, I would encourage you to learn this cross multiplication method, but don't forget this other way of just saying, hey, 10 times what number equals 30? 10 times 3. So that means we got to take the 3 and multiply the bottom number. 12 times 3 will get you 36. For those easier ones, that may be a very, well, it should be a quicker way if you know your multiplication facts. If you're a little fuzzy there, this cross multiplication is going to be the thing to save you. So here we go. Here's the new problems. Here are the problems. I do want to note though that I've actually got up here in the directions or the header, find the missing number for each proportion. You have to know that this setup is a proportion, or else you can't just go through and cross multiply or pretend they're proportions. You have to be told they're proportions so that way you can go and solve them. This third problem down here, this one is going to be the tricky one. This is where you're pretty much going to have to cross multiply to find the right answer. So pause the video, then hit play when you're ready. Okay, so 5 times 10,000 is 50,000. So we're cross multiplying here. And then 100 times m, cross multiply there, is 100m. When you divide both sides by 100, basically you're left with 500. So that's not too difficult. 500 would equal m. So that means this spot right here is 500. 33 times w, you can go ahead and do that. A lot of people, though, what they usually do with calculators is they go 99 times 3 and then they divide it by 33. We'll go ahead and pull the calculator. 99 times 3 is 297. And again, what I'm talking about is a lot of times people don't even write it out on their papers. They'll just go, okay, 297, and then 33 is the leftover number. So I'll just divide that by 33, and the answer is 9. And that's an easy way that you can do it if you have the calculator. And then over here, this is where it gets really nice. Let's do this. 105 times 40 equals 4,200, and then we divide that by 100. And the answer would be 42. So unless you know what you can divide 105 by to get to 42, or what you can divide 100 by to get 40, or what can you multiply 40 to get 100, you're not going to be able to figure that out. And let's go ahead and set it up the long ways. 105 times 40 is 4,200. 100 times h is 100h, and then you can just divide both sides by 100, and that's when we get h equals 42 for the answer. If you're having trouble with this, just stop by and see me, please. Usually, if I can sit down one-on-one with the person in about 3-4 minutes, I can have you feeling great about it with all the confidence in the world. If you think you're messing up on just one part, maybe just watch the video again, fast forward to the part that troubles you, and try to figure out why I keep doing it the same way, because it is a pattern. It's a series of steps. But remember, you have to understand this is only possible when you know this ratio on the left is equal to the ratio on the right, and that sets up a proportion. So that's the reason we're calling it a proportion.